Good evening to daughter and everyone here. So for today, for now, we are going to do the presentation for our artificial intelligence training project. So we are doing the neural network project. So as you can see right here, our group consists of 4 members. First one is Chun. Second one is Muhammad No Kuzari bin RUSLAN. Third one is DOSSAPHORN, and lastly myself, Continue. All right. So for the project title, we are doing the ANN system, which are the artificial neural network system, and also the dataset name is the bank marketing. So first, I would like to introduce to you. This is our project information in the topic. So we select the dataset with the topic. We predict whether a customer will subscribe to a term deposit based on various features, and the result should be yes or no only. So this is to predict either the customer will subscribe to the term deposit provided by the bank according to their attributes such as the ages, the educational background, marital status, and so on. So this is the data set that we get. We get the data set from the UCI. All right. So now we come to the journal paper. My groupmate will explain about this.
So now for the journal paper, there were 3 journal paper. So for the first one is from the DC publications. So this journal paper is about using a machine learning to improve the retail bank marketing by predicting the customer likely to buy term deposit. And also it analyzed data from a Portuguese bank campaigns. And also a random forest model have identified key factors like age and communication types, while an artificial neural network ANN achieved 91.82% accuracy in predicting customer purchase intents. So the results show that machine learning can make bank marketing more efficient and cost effective. So the second journal paper is from the DG Park. So this journal paper is about dataset of 45,211 people from the bank marketing campaign to train a multi-layer artificial neural network. So it's aimed to predict whether customer will open a time deposit account based on personal features. So compared to traditional statistic method, the MLNN achieved a 94.3% accuracy, showing it's more effective for predicting customer behavior. So the last paper is from Springer, and this Springer is about a customer profiling using RFM analysis, and K means clustering to group customer into the 3 segment, which is new, best, and intimated. And by analyzing customer behavior, it helps digital startup, especially in edutech, tailor content, offer personalized incentive, and create re-engagement strategy to improve customer satisfaction and support sustainable growth. So next will be explained by my groupmate.
So now we come to the dataset information. So the objective of this dataset is to predict whether a client will subscribe to a term deposit. So the result is yes, the client subscribed to the term deposit, and the result is no, if the client is not subscribed to the term deposit. So here is our screenshot for the dataset. Our dataset consists of around 4,500 set of data. So we decided to take only about 10% of the data. So it is around, we take 407. So 470 data, and we split the data set into a training set and testing set. So the ratio for the training set and testing set is about 80% and also 20%. So for 80%, it consists of 375 set of data, and 20% of the testing data will consist of 95 set of data. So here are the screenshot. For the training dataset, you can look through the dataset. All right. And this is the 95 set of data used for testing the testing dataset. This is the screenshot. All right. Now it comes to the variable definition. As you can see right here, right, the above here, we have 16 of the input, which are we mean by variable. Now I am going to explain what is the variable for this. What is the variable term of meaning? So the first one, we have age. Age is the ages of the client. It is simple. And the second one is the job, which is the type of job that the client is doing. And the marital status of the client. Fourth one is the educational background for the client. Third one, the default. This is the variable term default only. So it is mean by do the customer subscribe to the customer has credit or not to the bank. Okay. So the next one followed by the balance. Balance is not the balance left in the client's, but it is average balance. Average balance left in the client's account in the end of the year. It's the average balance, while not just the balance only. It is average. And housing loan status, whether the client have a housing loan or not. And also followed by the personal loan, whether the client has a personal loan or not. So this is the contact. Contact means by the type of communication for the bank to reach the customer. For example, the bank can reach the customer by using the cellular and also the telephone. This is not the same. Cellular is the smartphone we are using, and the telephone is the ancient time phone using. All right. Okay. The day, number of day from last contact from bank to client. Okay, and months, last contact month from last contact from the bank to the client. The last contact month and the duration, the number of seconds during the last contact with the customer. Okay, and also the campaign. Campaign means by the number of contact performed during this campaign. For example, if the bank is doing a term deposit program, and during the period for the term deposit program, how many times of contact do the bank reach to the customer? Maybe three times. Three times the bank calling the customer, or not even the bank calling the customer during this program. Okay, so the P days. P days is the number of days that pass by after the client was last contact from a previous campaign. Okay, the previous is the number of contact performed before this campaign and for this client. P outcome means the outcome from the previous marketing campaign. Previous outcome. Okay, so either the customer subscribe to the term deposit or not during the previous campaign. Okay, so Y is our target, which is also known as the output, and it means by whether the client subscribe to the term deposit or not. Okay, so now we come to the data processing. So for the data processing, we do the data variable value encoding, also the data normalization. So we encode the data as the following. As you can see, for the age, we encode the data as 0, 1, 2, 3, 4 by splitting the range for the age. You can see right here. And for the client job, we encode the job like this from 0 to 11, because there are variable value with the string. So we have to encode it into number before we train the data. We need to we need to make it into number. So I encode this, and the marital status only 4, 0, 1, 2, 3, and the education is 0, 1, 2, 3 also. For the default either 0 or 1 only, because it is yes or no only. For the balance, I divide into 0, 1, 2, 3, 4, 5 with the range defined here. And the housing loan and personal loan, it is either yes or no only, 0 and 1. And a contact cellular, telephone, and unknown, 0, 1, 2, 3, 0, 1, 2 only. So the day start from 1 day out to 10 days, it is 0. 11 out to 20 is 1, and 21 up to 31 is 2. This is the contact date. So we only start with 1, while not start from 0. Yeah, this is the contact, the direct, the date. Okay, so next is a month. We split it we split it 3 months for a range. The first, January, February, and March. Second, April, May, and June. Third, July, August, September. And last one, October, November, and December. So for the duration, contact duration, we split also 0, 1, 2, 3, 4. This is the encoding. And campaign is 0, 1, 2, 3, or 4. But 0, 1, 2, 3, 4 also. And the P days also 0, 1, 2, 3, 4. And previous is also 0, 1, 2, 3, 4. And the outcome is 0, 1, 2, 3. All right. So for the encoded training data, later you can refer to the training dataset.csv. I put together with the zip file. And then for the encoded testing data, you can refer to the testing dataset.csv, right? So next step, we do the data normalization. This is the formula we use to normalize the data. This is what I get from the PowerPoint slide provided in the column here. So this is, as you can see, I put the formula that we use for each of the variables. I changed the maximum only, and while for the others all the same. You can see this is 1, and this is for the education, it is 3. And for default, we no need to do the formula because it is only 0 and 1, which comply with the new maximum and new minimum, which is 1 and 0. So we doesn't need to normalize for this type of data, only 0 and 1. For this normalization, we try to make the variable of each data, make the data of each variable to maintain within 0 and 1 only. So we use this formula, okay? And for the normalized training value, you can refer to the normalized training.csv. And for the normalized testing value, you can refer to the normalized testing.csv. And now we come to the neural network architecture. So for our neural network, we design for 4 layers, which with 1 input layer, 1 output layer, and 2 hidden layer. Here is the description for the neural network architecture. You can refer. And now we describe about the training for the data set. I will pass to my teammate, Chun.
Okay, now I will explain the training process of our neural network model. We train the artificial neural network using the gradient descent optimization with the goal of minimizing the binary cross entropy loss function, which is commonly used in binary classification problems. The learning rate was set at 0.01 and the training was run for 1000 epochs to allow the model to learn effectively over time. For the activation function, we use the ReLU for the hidden layers and sigmoid for the output layer to produce a probability between 0 and 1. We trained the model using 375 training samples, each with 16 input features, and tested it using 95 samples, also with 16 features. During training, we tracked the loss value at different epochs. For example, at epoch 0, the loss started at 0.2500. By epoch 500, it reduced to 0.1283. And finally, at epoch 999, it reaches 0.1164. This shows that the model was learning and improving over time. The final test accuracy achieved was 89.47%, which indicates strong performance on unseen data. Next, I will explain how we evaluate the performance of our trained model. We conducted performance evaluation using the testing dataset, which consists of 95 unseen samples. This allows us to measure the model's ability to generalize. We use several standard metrics to evaluate our model's performance. First, we look at accuracy, which tells us how many of the predictions were correct overall. Next, we use precision, which measures how many of the cases the model predicted as yes were actually correct. Then we consider recall, which tells us how many of the actual yes cases the model was able to correctly identify. After that, we use the F1 score, which balances precision and recall. This is useful when we want to consider both matrices together. And finally, we use the confusion matrix, which break down the prediction into 4 categories, which are true positive, false negative, true negative, and also false negative. These matrices are especially important in bank marketing, where missing potential customer can lead to lost opportunities. We also did an error analysis. The model only misclassified 10 samples. These errors may have been caused by overlapping feature patterns, noisy data, or the small size of the dataset. Lastly, we look at the loss curve, which show a consistent decrease in training loss across the epochs. This indicates the model was learning effectively without signs of overfitting. Thank you. That's all from me. Thank you.
Right, now we describe about the result, which were described by Muhammad QHUZAIREY.
So for result, first present the classification prediction result. The prediction results show how closely the model's prediction align with the actual test tables. The majority of the predictions are correct, as seen by the true result in the table. This indicates that the trained ANN model has successfully learned patterns in the data, allowing it to make accurate predictions on unseen sample. The few false results suggest some misclassifications, which may be due to overlapping features or noisy data. Overall, the consistency in the true outputs reflect reliable model behavior. We tested our model using a testing dataset of 95 samples, but we only take a sample of 9 dataset to show in the table to compare the actual labels with the predicted one, which also include a column to indicate whether each prediction was correct. To visualize the overall prediction trend, we created a bar chart showing the distribution of predicted classes. Most predictions were for class 1, which reflect the dataset's pattern. This help us see both the accuracy and the behavior of the model's output clearly. Next, present the testing set accuracy and performance. The trained AN model was tested on 95 data samples, and the model achieved accuracy of 89.47%, which means almost 9 out of 10 predictions were correct. A precision of 89.47%, showing that when the model predicts a subscriber, it's correct most of the time. A recall of 100%, meaning it correctly identified all actual subscribers, and a F1 score of 94.44%, which balance both precision and recall. The model achieved. Okay, so we also included the confusion metric to show the breakdown of correct and incorrect predictions. Notably, there were no false negative, which is important because we don't want to miss any potential subscribers in a marketing context.
So in this project, we already successfully developed an activation neural network model to predict whether a customer will subscribe to a term deposit while using the bank marketing database. So this model architecture includes 2 hidden layers, which is ReLU activations function and also a sigmoid output layer. So we apply exponential machine learning technique such as data encoding and normalization, which help improve the model performance and stability. So after training the model over 1,000 epochs, we achieve a test accuracy of 89.47%, which is a perfect recall of 100% and a F1 score of 94.44%. So with this result, it reflects the model's strong ability to identify customers who are likely to subscribe. So throughout this training, we observe a consistent decrease in loss and minimal signal of overfitting, which indicates that the model was learning effectively without memorizing the training data. So overall, the model demonstrates solid generation to unseen the data and achieve the objective of our project. That's all for me.
Okay, here is the reference that we are using, and we would like to come to the source code. Also will be explained by the DOSSAPHORN.
So for this one is the source code. So the source code is about to read the Excel files and also to load the training and testing database from the CSV files. So for the second one, the code is define the input layer, also the output layer and the hidden layer, and also analyze the weight and the bias. And for the third one, this code is define the function used, which are activation functions, forward propagation functions means square root functions, the drive active function, and backward propagation functions. So for the fourth one is a code for the training loop. And the last one is the evaluation and safe predictions.
All right, that's all from us. Thank you for your patience and listening.